Grab your notes for sine, cosine, and tangent graphs, and let's get started. We're going to start with the sine graph and the unit circle. So although you don't maybe know the unit circle in all of its points, you certainly know if you go right 1, that's 1, 0. If you go up 1, that's 0, 1. Left 1 is negative 1, 0. And down 1 is 0, negative 1. This has nothing to do with sine, cosine, or tangents, just graphing 1 up, down, left, and right. And you also know that every point on the unit circle goes cosine, sine. So we are looking at y values when we look at sine. So we want to connect the unit circle to a graph that's more left and right. So rather than spinning around, we're going to graph it left to right. And so over here you can see on this left, we have a little t-chart. This isn't really x, it's theta, because as you know, along that x-axis, these are your angles. And so x and theta are basically the same thing. So if our angle is 0, which is right here, the y value is 0. Pi over 2, that's straight up. The y value is 1. At pi, we're over here now, the y value is 0. 3 pi over 2, we're going down, and there the y value is negative 1. And then, of course, we come back up to here, and that's back to 0. So if you think about spinning this unit circle, I can't get rid of all of the points, but we'll get rid of some of them. We went, if we start here, this is 0, we go 0, up to its highest point, back to 0, down, back to 0. So 0, up, 0, down, back to 0. And that's what this graph does. So if we think about doing this left and right, let's plot these points, 0, 0. Now with this graph, every 3 spots to the right is going to be 90 degrees or pi over 2. So if we go right 3, then this is where pi over 2 is. I know it's not marked, but that's where it is. And then pi is back to 0. 3 pi over 2 or 270 is down, and then 2 pi is back to 0. So if you follow the pattern, it goes 0, up, 0, down, back to 0. That's how we're going to graph this. We're not going to calculate points, and we'll go through this with some other numbers. This is just the parent function, but that's how this will be graphed. And we'll go, like I said, we'll go through it again and again. So you know from the other day that period is if you repeat, right? So if we take this whole section and we basically copy and paste it and put it over here, we get a periodic graph. And then if we copy and paste it, we can do it over and over and over again. So this is your sine curve. And what I have in this yellow box, which I know is hard to see, I'll put it in this green box. This is where one whole cycle is. So left to right, that's our period. And the period goes from 0 to 2 pi, so it's 2 pi. Amplitude is 1/2 the max minus the min. So this is 1 minus negative 1 divided by 2. So this is going to be 2 divided by 2, so our amplitude is 1. Midline, of course, is the line that cuts the graph in half this way, or if you count your amplitude from the max down and from the min up. So these are all things we did the other day, and this is why, because now we need them. Now for this domain, and there's no arrows on it, but it does go forever. We could just keep going and repeat this pattern forever. So this is negative infinity to infinity. But the range, the bottom number, the lowest number is negative 1, and the highest number is a positive 1, which means the minimum y value, or the minimum value, is a negative 1, and the maximum value is a positive 1. It is these graphs that we're going to start to graph today. So now we're going to go through the cosine, and then we'll kind of take a little time out and go back over all this stuff, because sine and cosine are very, very similar. Let's head back to our unit circle and these points. So these are the same points that we just talked about, but now we're going to take a look at the x values. The x values, of course, have a different pattern than the y values, so the graph will be different. So at 0, we're looking here, we're looking at x. At 0, that's a 1. Pi over 2, we're going straight up, that's 0. Over here to pi, the x value is negative 1, and then here we're at 0, and then, of course, back to 1. So let's put these points on the graph. 0 goes up to 1. And remember, you got to go 3 squares till you get to pi over 2. And that's at a 0. At pi, we're down. 3 squares to the right, we're back at 0. And at 2 pi, it's up at 1. And this is the entire cycle. Now, this is not as easy to see, but when you connect this, it looks a lot like the sine curve. So it's going to be curvy, kind of like slow, like a rolling curve, like a roller coaster even. So this, don't connect it like a V. That is what the cosine curve looks like. And we could copy and paste that and have that kind of come back over this way, and we would just be able to continue this on. And we could keep doing that for as long as we needed to. So again, the period repeats, or the period would be from 0 to 2 pi, just like sine. So the period is 2 pi. The amplitude is from the midline down or from the midline up, how far up and how far down it goes from the midline. So our amplitude, or you could do max minus min divided by 2, and that is going to be a 1. Our midline, of course, is y equals 0. Domain is the same. Range is the same. And minimum is obviously -1 and maximum is +1. So for sine and cosine, they have all the same parts. They just have different values. So they are not the exact same graph, but they're very similar. So that's what the graph looks like. Let's tie this into period and amplitude. Now, what's nice about the sine and the cosine, and really the tangent, is that it goes in order. So amplitude will be associated with A. So the number in front of the word is your amplitude. The number in front of your X is the value for B. And B is calculated with the period. So this is the formula to figure out the period. On the parent graph, it's 2 pi because the parent graph is written like this, y equals sine of X. So the number in front, that's a 1. So your amplitude is a 1. In front of the X, that's a 1. So the period is 2 pi divided by 1. So that's why it looks like 2 pi. So the period, the B value rather, is not going to be seen on the graph, but instead it's going to help you calculate the period. So let's draw some graphs. We're not going to, I know I made a T-chart before, but we're not going to make any T-charts. We're not going to use the calculator. We're just going to draw the graph based on the pattern. Super easy to do, but you have to know the pattern. So let's just go through this. Now we're going to graph y equals 3 sine of 2 theta. So the amplitude is the first number, just plain and simple. It's always positive, it's just that first number. If it's no number there, it's a 1. The period is 2 pi divided by b. Well, the b here is 2. And that crosses off, so our period is pi. Then this is what we're going to do. Amplitude, as you know, controls up and down. Period controls left and right. We're going to graph this. This is where the y-axis, and this is the x or the theta axis. You're going to go 1, 2, 3, 4. Always 4, and that's where the period goes. Whatever it is, 90 pi, you write it there. All right, so that's going to always be 4 marks to the right and then the pi. Please also take this middle and write down the angle measure there. It's pretty easy. All you have to do is take pi and divide it by 2, right? So that's half, so pi over 2. Now the amplitude is going to run up and down, so we know we have to go up 3 and down 3. And now we just graph it. So I don't know if you remember the pattern for sine. Sine goes 0, up, 0, down, back to 0. And you might think, well, how high up does it go? It goes up the amplitude, so it goes up 3. How low does it go? It also goes down 3. Remember, you always count from this middle. This is the middle. Wherever the zeros are, that's the middle. So 0 up, 0 down, back to 0, done. Connect the dots. So we'll only ever plot 5 points, and you connect them. Let's try the cosine curve. Amplitude, first number. You can call it 1.5 if you want. Period is 2 pi always divided by b, which is 3. That does not reduce. So even though this might seem like we have weird numbers, it really doesn't matter. 1, 2, 3, 4. Put the period right there. Now we have to do half of 2 pi over 3. Half of, well, half is 1/2. Of means multiply. So we're going to take the number and we're going to take half of that number. So you just multiply by 1/2 if you get stuck. When you multiply fractions, you go straight across the top, straight across the bottom. So this little middle mark here is pi over 3. Now 3 over 2 is 1.5. So I'm just going to go up to 2 and down to -2. Now cosine. Cosine starts high. How high? Its amplitude. Ends high. Also the amplitude. So it starts and ends at the max. Exactly halfway is where the minimum is, which is why I want you to write that number on there. I know I just colored in my number, but that's okay. And then in between the high and the low, it's a 0. And you connect the dots so that it's a smooth curve and not pointy. Let's do sine again. Amplitude is 5. Now for this, the b value is 1/4, so it's 2 pi divided by 1/4. Think of it as dividing fractions. Don't do 2 pi divided by 1/4 and then say, I don't know what to do with that. You created a problem you can't solve. That's not a good idea. So this is multiplying fractions. So we're just going to invert or flip over and multiply straight across the top, straight across the bottom. We get 8 pi. Now 8 pi might sound like something you have no idea what to do with, but we honestly don't care what the number is. You do the same thing. 1, 2, 3, 4. This is where the period goes. Also, please write down what the halfway spot would be. We're going to go up 5, and we're going to go down 5. Sine. 0. It always starts at 0. Sine, then at the very next mark, this little mark, you line it up. We're going to go up to 5. 0 up, 0 down. So you line this up right here, -5, back to 0. 0 up, 0 down, back to 0. So really and truly, you can see every time we draw the sine graph, it pretty much looks the same. These periods are very, very different. Pi and 8 pi are completely different numbers. The amplitude is different, but the graphs are the same, which is what makes these really pretty fast and easy to draw. Tangent has a completely different pattern than sine and cosine. So we kind of isolated it here. Let's think about this unit circle. The tangent is slope. So this is such a steep slope that this is undefined. And that's at pi over 2, 3 pi over 2, negative pi over 2, anything with it's got a fraction and it's undefined. Well, how do you graph undefined? Let's take a look at that in a minute. This line, this is the 0 and pi line, that slope is so flat that it's 0. So we don't have a lot of information. Also, if you notice, it starts at negative pi over 2. This is essentially important that you remember that it starts on the negative. Everything else starts at the y-axis. So negative pi over 2, remember our pi over 2 is 3 spaces. Undefined is a vertical asymptote. An asymptote is a line that the graph does not touch or cross. Vertical means just run straight up and down. So negative pi over 2 is an asymptote. Then you can see the point 0, 0. 1, 2, 3. This is another asymptote because it's where it's undefined. At pi, it says the value is 0. And then we go 1, 2, 3 more spaces. And this is another asymptote. And what's nice about this is the graph is done. All you have to do is draw it in. The tangent looks like the graph y equals x to the third. It's not this graph, but it looks like that graph in that kind of hugs that asymptote, crosses over, and then it hugs the other asymptote. It is not a straight line. Do not draw it so that it touches the asymptotes. So don't draw this so that, it looks like, sloppy and it sticks out. Please make sure that you pay attention to the asymptotes. That's why they're there. They're guidelines. It should not touch or cross that asymptote. Now, what's different about this is one cycle right here. And this is from negative pi over 2 to positive pi over 2, which is basically 1 pi. So we have a different period than the others. Also, because we have arrows, top and bottom, this thing goes up forever and down forever. So we have no midline, which means we have no max and no min. We have no amplitude. I said midline, so we have no amplitude, sorry. The midline, though, of course, is right where the other ones are, right at y equals 0. Now, the domain, we've got a bunch of gaps in our domain. So the domain are the x values as we look at it left to right. And any place there's an asymptote, that's considered to be a hole in the domain. So the domain on this is real, real weird. I'm going to write it out. You probably won't be asked about it again, but just so you can see what it is. x cannot equal pi over 2 times k, and k is an integer. What this does is, if you think about putting a number in there, 1, so pi over 2 if you put in a 3, 3 pi over 2 if you put in -5, these are all places where the asymptotes are, and the domain doesn't exist there. But the range, as you can see, it goes from -infinity to infinity. Now, it does repeat, right? So just every little section has that same range. The graphs, the equations rather, are written the same, where your amplitude is the first number, b is the second number. The period here is pi. I don't know what happened to it. It must be on the next page. Period is 1 pi over b, which is maybe the hardest thing to remember because you want to just do whatever the sine and the cosine do. So real quick, I want to redraw this graph again because it's kind of weird, but there's a definite pattern to it. They all are just patterns. So you're going to do this, right? And you know the period is pi because we're going to do the parent graph. So you're always going to do this. Notice I drew space to the left. You're going to always do this. You're going to go 1, 2, that's where the period goes, and then do one more. Then on the other side of the y-axis, you're just going to put one mark. And this is where you start. It starts with an asymptote, so it's going to go asymptote, 0, asymptote, 0, asymptote. It will do that every single time. And then all you're going to do is draw this in. All right, on the right, touches that 0, crosses over, and goes to the left. All right, so there's the pattern. Let's apply it to some with some actual numbers. So it says to name the amplitude period, and we're not doing this. 0 is, I don't know why it says that. So the amplitude is the first number. Well, we don't have an amplitude, even though it's there. Notice that the y-axis, there's no marks on it. We don't care. We're not going to do anything with that y-axis. But the period we definitely need. The period is 1 pi divided by b, which is 2. Okay, so pi over 2. So again, the pattern is space to the left, draw this to the left and to the right. 2 marks, period. 1 mark to the left, 1 mark to the right. So you should have still have 4 marks. Asymptote, 0. Asymptote, 0. Asymptote. Draw it in. Now for this one, we have an amplitude, of course, which is, well, there isn't one. I know it says 2/3, but you ignore that, and we don't graph it. The period is pi divided by 2/3, which is going to be pi over 1 times 3 over 2. Straight across the top, straight across the bottom, 3 pi over 2. So again, here we go one more time. Give yourself space to the left. 1, 2, period. 1 more mark. 1 mark to the left. It starts over here, right? Make sure you start to the left of the y-axis. Asymptote, 0 at 0. Asymptote, 0, asymptote. Draw in the curve. So again, no y, no t-charts, no calculating the points, none of that stuff. We just use the patterns over and over again. So you have to know the patterns in order to draw the graphs. So try the homework. Your graphs should look the same, just have different numbers on the x and the y axis.